In solving radical equations, the first thing we want to do is isolate the radical on one side of the equation. So in this example, what I want to do is get this square root of 3 minus x all alone, and then I want a constant on the other side if possible. So first thing we'll do is take care of this plus 2 on the outside, so I'm going to subtract 2 from both sides of the equation. So that'll give me 3 times the square root of 3 minus x equals 29 minus 2, which is 27. Then I need to divide that 3 away, so I'm going to divide both sides by 3. So then I have the square root of 3 minus x equals 9. Then what I'm going to do is step 2, which is to raise both sides of the equation to a power to cancel the radical. So what this will look like is I'm going to put the left-hand side in parentheses, right-hand side in parentheses, and I'm going to put an exponent. I'm going to choose an exponent that cancels out with the radical. So if this was a cube root, I would want to use an exponent of 3. If this was a fourth root, I want to use an exponent of 4. So because this is a square root, I want to square both sides of the equation. So when I square, the root and the exponent cancel out with each other, so then I'm just left with what's underneath. So in this case, 3 minus x, and then 9 squared is 81. And then it becomes something linear to solve. So I'm going to subtract 3 from both sides. So I'll have a negative x equals 78. And then, because I have that negative there, you can do this a few different ways. You can either think of it as multiplying both sides by -1, or you can think of it as dividing both sides by -1. But basically, use a negative to make that a positive x, and then 78 times -1 makes negative 78. Then we have to check solutions. We absolutely have to, because this also has the possibility of extraneous solutions. So what we'd want to do is go check, and I can show you with the calculator here. So taking 3 times and then root, and we want 3 minus, and then we're doing negative 78. And then outside of the square root, which you can either use your mouse to click away or hit the right arrow on your keyboard, and I'll jump you out of there. And I want to do plus 2. So then we can see we get that 29 that's working. So that checks out, so that's our solution. All right, let's try this with 2 more examples here. So I want to get this square root of 8x plus 5 all alone on one side of the equation, so I'm going to subtract 4 from both sides. So I'll have square root 8x plus 5 equals 10 minus 4 is 6. I'm going to square both sides of the equation. So then the square root and the square cancel out with each other, so then I just have 8x plus 5 left over, and then equals 6 squared, which is 36. I'll just subtract 5 from both sides. Divide by 8. So I end up with a fraction, x equals 31 over 8. If you get to fractions and you're not sure whether or not it reduces, Desmos has a nice feature, so if you type in 31 over 8, it'll give you the decimal form. It also has this button for convert to fraction, and it will always give you the more reduced form. So if you ever need practice with your fractions, Desmos has good support in there. Let's plug it in and make sure it works. So 8 times 31 over 8 plus 5, and then outside a plus 4. And we get a positive 10, so that all balances out. All right, one more example here. So I want to get this square root of 16 minus 3y all alone on one side of the equation. So I'm going to subtract 2 from both sides. So I'll give us y minus 2 equals the square root of 16 minus 3y. Then I'm going to square both sides of the equation. So at that, I'm going to use parentheses. So I'm squaring this y minus 2, And as a reminder, because a common mistake here is to change that to y squared minus 4, but that is not true. Think of it as y minus 2 times y minus 2, and that can help trigger the memory that you actually need to FOIL it. Because if you just do y squared minus 4, you're missing out on this middle term. The square and the square root cancel out, so we'll have 16 minus 3y. So FOILing will end up with y squared minus 4y plus 4 equals 16 minus 3y. Now we can see that we have something quadratic, so I want to move everything to one side of the equation. So I'm going to add 3y to both sides. So we'll have y squared equals negative y plus 4 equals 16. I'm going to subtract 16 from both sides, that now I have 0 on one side of the equation. So y squared minus y minus 12 equals 0. So factoring, this will be y minus 4 times y plus 3 equals 0, which will then split into two possibilities. So y minus 4 equals 0, or y plus 3 equals 0. So y is 4, y is negative 3. But before we're done, we need to check. So what we really want to be careful of is we don't want to make negative numbers underneath that square root. So what we could do is think about if we plug in positive 4, so that'll be a 16 minus 12, which is 4. That's all going to be okay. But just to double check, we're plugging in a positive 4, so we'd have 4 on one side of the equation, and I want to see if this expression would also equal 4. So 2 plus the square root of 16 minus 3 times 4 gives us 4. So that works great. If we plug in negative 3, so 2 plus square root 16 minus 3 times negative 3, that gives us something completely different. That doesn't work out. So with that, it's not a solution. So that's our extraneous solution. We're going to throw that out, and y equals 4 is our one and only solution. So with radical equations, you'll end up, if it's a square root, you'll square both sides. You might end up with something quadratic to solve. You might end up with something linear to solve. You just use the previous methods that we talked about.